Pre-algebra, lesson 112, probability part 1. Probability can be a little confusing at first, but once you start to logically understand it, it becomes very, very simple. And I think the book does a very good job of explaining probability. It's as simple as this fraction right here. Probability is the number of outcomes that you desire, or the number of outcomes that you're looking for, over the total possible outcomes. So the way that I normally write that is like this. I would write probability as a fraction. The numerator will always be the number of desired outcomes, or the number desired over the number of possible, right? So those are some logical concepts that will help us understand probability. So to kind of get this, you just have to hear a practice problem, and we'll see how that practice problem can relate to this fraction or this ratio of probability. So the way probability works is it's not always an exact thing either. So probability is technically what should happen. It's not exactly what will happen, right? So it's not an exact science. It's not a perfect math, but it is a pretty good thing that helps us find out some ideas on how things are most likely to go. So probability is a good way of saying it is the most educated guess around. Now let's do a practice problem. They tell me I'm doing problem number 3 on page 349. They tell me one dice is rolled. What is the probability of getting a 3 or a 4? So if one dice is rolled, what's the probability of getting the number 3? Right? So, or what about the number 4 if I roll a dice? Now, to answer this, I have to understand what a dice is and what in the world is happening. So, logically, a dice is a little number cube, right? And it has 6 faces. So hopefully you've all seen a dice before, and we know that the faces look like this. Also, in our study of cubes, we know that since it's a number cube, there's only 6 faces possible. And so we see that there's 6 options for a dice. So if I roll a dice, it's going to land on one of these 6 options. Now I know there's a jokester out there. One of you is thinking, well, Mr. Claiborne, what if it gets stuck in a crack and it doesn't land on any of the sides? You know, technically that is possible, but that is such an unlikely scenario that it's not something we account for in probability. So probability is very straightforward, not a whole lot of trick questions in probability, so we don't have to worry about what happens if the dice gets stuck in a notch or a crack and doesn't land on any of the sides. So if we look at this, there's 1, 2, 3, 4, 5, 6 sides that it could land on. That is our number of possibilities, right? So if I'm going to do the probability of what happens if the dice were to land on a 3, the number of possible options is 6. That means my answer is going to have a denominator of 6. Now, number of desired. Some of you are going to be very tempted to put the number 3 here. But if we look back at the number of options, how many of these options have an answer of 3? Only one, right? Only one of these options have the number 3. So that means my number of desired outcomes is not 3, but 1. Which means the probability of rolling the number 3 when I roll a dice is 1 out of 6. Okay? Now let's do the number 4. Well, if I roll the number 4, I'm still rolling a dice, still have 6 possibilities, so my denominator is the same, right? 6 possible outcomes. Now, how many faces on the dice read the number 4? Only 1. So the probability for rolling the number 4 would still be 1 out of 6. Okay? So there's lots of ways that we can do probability. Another way we can do it is if we have a bag full of marbles. This is another one that happens a lot. I'll do practice A on page 348. They say there are 16... actually, you know what? Let's not do practice A, because I realize whenever we do self-review lessons, sometimes those practice problems end up being on the self-review. I'll go ahead. We'll do problem number 1 on lesson 112. We'll do page 348, problem number 1. They tell me there are 22 marbles in a bowl. Okay. So there are 7 black, 5 red, and 10 blue. So let me get my black, red, and blue pen. We'll make my bowl purple, since that's not one of the colors being used. Right? So let me back out a little bit. I've got a purple bowl. It's got 22 marbles in it. And I'm going to go ahead and draw this bowl, and then you guys will come back and see the... Ta-da! Okay, so I've got my purple marble bowl. And in this bowl, I have 7 black marbles, 5 red marbles, and 10 blue marbles. Right? So for blue, there's 10. For black, there's 7. I just realized there's no way to really distinguish that using words. And then red, there are 5, right? So I've got all those marbles in the bowl. They want to know what is the probability that if I were to draw a random marble from the bowl, let's say I stick my hand in the bowl, I grab one marble at random with my eyes closed. What is the probability that the marble is either black or red, right? So what is the probability that I get a black or red marble? Well, to do this, I have to understand what is the total number of possible outcomes. So to figure out how many outcomes there are, if I reach in blindly and grab one marble, I have to know how many marbles are in the bowl. So how many marbles are in the bowl? Well, I can count them all, or I can add these up. So 10 plus 7 is 17. 17 plus 5, now that gives me 22. So I've got 22 marbles in the bowl. So that's 22 total possible. So 22 possible, which means my denominator for this probability is going to be 22. Now, what are they asking for? What is the outcome they desire? They want to know what's the probability that the marble is either black or red. Okay, so if it's black or red, they don't care if they get one of the 7 blacks or one of the 5 reds. So what that means is I can add these two numbers to figure out the desired outcome. The desired outcome being black or red would be 7 plus 5, which means the desired outcome is actually 12. So 12 out of 22. That would be my probability, except we have to reduce our probabilities. Probabilities are fractions. They can be reduced. If I divide these both by 2, I end up with 6 out of 11, and that becomes the actual probability. So the probability of drawing a black or red marble becomes 6 out of 11. That's how probability works. It's this basic ratio, number of desired over number of possible. So you have to logically think about how many possible outcomes there are, do a little bit of addition or subtraction to find out that number, and then compare that to your desired outcomes. An important page to bookmark on your in your textbook would be page 348. Page 348, you have this little graph here. This graph is showing you what happens whenever 2 dice are rolled. So they'll have multiple problems in this book where they'll say, hey, we roll a red die and a green die, right? The number of possible dice rolls when you roll 2 dice, there are 36 possible outcomes, and that's what this chart is showing, right? So each one of these numbers is showing one outcome. So that's 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 36. Okay? So there's 36 ways that you can get answers if you roll 2 dice. The reason why this chart is useful is because if they say, I want to know what the probability is of getting the number 8 when I roll 2 dice, you can look at this chart and you say, hey, 8. There's 1, 2, 3, 4, 5. There's 5 possible ways I could get the number 8. Or they say, I want to know what's the probability of getting the number 4 if I roll 2 dice. Well, you go to this chart and you go, oh, 1, 2, 3, 4. Oh, there's four ways that can happen. Right? So this chart is very, very useful for probability when you're doing 2 dice at a time. And as you do more and more of those problems, you'll kind of get a feel for how many options there are. That's all there is for this lesson. If you have any questions, let me know on the school website, and I will see you in class.